Hey guys, this is Professor Janacek, and I want to go over a couple of interesting integrals. We're going to start with the integral of the natural log of x dx. Now, we all know how to take the derivative of the natural log of x, but what about integrating the natural log of x? We're going to use integration by parts. So let's see. To begin with, I need to figure out what am I going to let u equal and what about dv. So we'll start by letting u equal the natural log of x. In this situation, the only thing left for dv is just dx, which makes this one a little hard to see for integration by parts. But if we go with that, then we know that du, I can take the derivative of the natural log of x, that's 1 over x dx. But yes, you could write that as dx over x. And then what about v? Well, v would be the integral of dx, which is just x. Yes, there's the arbitrary constant, but I will collect all of those arbitrary constants and add that in a little bit. So back over here, what do we have? Well, recall I am looking at this as the integral of u times dv. Integration by parts, we know that the integral of u dv is u times v minus the integral of v du. By the way, I do like to take a look at it as in this way. I take u times v and then the integral of v du. Maybe that'll help, maybe that won't. All right, so continuing on, let's go ahead and fill in our blanks. U is the natural log of x. V, I just determined is x, minus the integral of v, again, that's just x, times du, which is 1 over x dx. And again, just as a reminder, the arbitrary constant that I would have gotten when taking this, completing this integral, I will actually add on here when I complete this integral. All right, so if we simplify this, that gives us x times the natural log of x minus the integral of, oh, look at that, x times 1 over x, that's just a 1, so I'm just going to integrate dx, which I can do quite simply. That's x times the natural log of x minus the integral of dx is simply x, and then plus our arbitrary constant. Therefore, the integral of the natural log of x dx is equal to x times the natural log of x minus x plus c. All right, let's take a look at this other one. It's looks like it could be a little more complicated, but it's not too much worse than the first one. We're going to integrate x times the natural log of x dx. So we've got an extra little x in here. I'm going to start off kind of the same way. Let me first rewrite this one. I'm going to take the natural log, kind of put it by itself, and then combine the x and the dx. There's my polynomial. So just like before, we will let u equal to the natural log of x, and dv is x dx. Then du is 1 over x dx. Again, you can write that as dx over x if you prefer. And v would be the integral of x dx. Oh, well, I can do that quite simply. That's x squared over 2, or 1/2 x squared. Again, that arbitrary constant I'll combine over in my problem. All right, so let's take a look. What do we have? This is the integral of u times dv, which we know, again, it's u times v minus the integral of v du. So that gives us uv minus the integral of v du. Filling in those variables here, that gives us the natural log of x times 1/2 x squared minus the integral of 1/2 x squared times 1 over x dx. If we clean this up a bit, that's 1/2 x squared times the natural log of x minus, I'll factor that 1/2 out, 1/2 times the integral of, let's see, we end up with, we have x squared times 1 over x. Well, that's just the integral of x dx. That's not so bad. Keeping this first term as is, the second term becomes negative or minus 1/2 times integral of x dx. That's again x squared over 2 or 1/2 x squared. Here's where my arbitrary constant will come in. So that's going to be plus c. Cleaning this up even more, we have 1/2 x squared natural log of x minus 1/4 x squared plus c. And there we go. The integral of x times the natural log of x dx is equal to 1/2 x squared times the natural log of x minus 1/4 x squared plus c. I will let you know on occasion I have seen this written with a common denominator, so sometimes you might see this as 2x squared times the natural log of x minus x squared over 4 plus c. And there you go. Some very interesting integrals. Enjoy!